right, on the first one, when I take the derivative of, now all of these things are getting the derivative taken of them with respect to x. Right? So when I take the derivative of x cubed, I'll get 3x squared, but it was an x, so I'm good. All right, now when I take the derivative of this next thing, it's in two parts. So I have to product rule it, which after grading that last quiz, many of you guys need to take a look at. So if I take the derivative of the first, I'm going to get -1, and it was an x. I'm okay. Times the second, left alone, plus the first, left alone, times the derivative of the second, y prime, plus the derivative of y squared with respect to x is going to be 2y, y prime. Derivative of 4 is 0. All right, so everything that has a y prime in it stays, everything that doesn't has to go. So I'm going to get -x y prime plus 2y y prime equals y minus 3x squared. So I had to add y to both sides, and I had to subtract 3x squared from both sides. All right, pull out a y prime, leaves me with 2y minus x equals y minus 3x squared. Divide both sides by 2y minus x, and y prime will equal y minus 3x squared over 2y minus x. Right. X cubed minus 3x squared y plus 2xy squared equals 12. Now I can take the derivative of this thing, the first one with respect to x, that's easy, 3x squared. Now the next one, I have to break it up into two parts. So the derivative of the first with respect to x is going to be -6x, right, times the second left alone, plus first left alone, times the derivative of the second. Right, plus, now I got to do the same thing to this thing. So the derivative of the first is 2 times the second left alone, y squared. Plus the second times the derivative of the first. Okay, that's what I just did. I'm backwards. Plus the first left alone times the derivative of the second. 2y, y prime. That and all of that. Just want these guys. And that's going to equal 0, if the derivative of 12 is 0. All right, so let's make this look a little nicer before we start doing stuff to it. So 3x squared minus 6xy minus 3x squared y prime plus 2y squared plus 4xy y prime. Everything with a y prime and it stays, everything that doesn't has to go. So I'm going to get 4xy y prime minus 3x squared y prime equals 6xy minus 3x squared minus 2y squared. Pull out my y prime, leaves me with 4xy minus 3x squared equals this mess. Supposed to be. It's not keeping up. Okay. That puts me at y prime equals 6xy minus 3x squared minus 2y squared all over 4xy minus 3x squared.
I got cancel. It's clear. I got like that, but all this my signs were the opposite. I got 3x squared plus 6xy plus 2y squared over 3x squared minus 1. Like the opposite. How totally weird.
Like the top and the bottom?
Yeah.
So if you pull the negative out of the top, you can have this. And if you
Okay,
pull the negative out of the bottom,
right.
you'd have, and a -1 divided by a -1 would be.
So it's right.
So you got to think about it.
Is
that what you're telling me?
I didn't ask this one.
Okay, 11.
So I figured it was something like that. Like, I don't
Trigging it. Okay, now, you only use a y prime when you take the derivative of y directly. Okay, so when I take the derivative of sine of x, what's that? Cosine of x. And if I take the derivative of the inside, I just get 1. And it was the derivative of an x, so I don't have to worry about that. Okay. Plus, all right, now, this is a cosine of the first, so I can just treat this like a regular 2 coefficient. I don't have to do anything with it. But when so it's going to still be there. So the derivative of cosine of 2y is what, though? Negative sine of 2y. Now, do I need to tack a y prime on there? No, because I didn't take the derivative of the y directly. But when I take the derivative of the inside for the chain rule part, derivative of 2y is 2y prime, because that one I did take the derivative of that y directly. Equals 0. All right, so I get cosine of x minus 4y prime sine of 2y equals 0. So the cosine of x has to go. So negative 4y prime times sine of 2y equals negative cosine of x. Divide everything by negative 4 sine of 2y. Leaves me with y prime. Then I have to do the same thing over here. So I get negative cosine of x over negative 4 sine of 2y. The square of a negative divided by a negative, I don't really need that. Just drop those negatives. No, it's not. Because one's of an x and one's of a 2y. They'd have to be the same for me to make that substitution.
You're just being a jerk.
Yeah. Oh, okay.
You're just being a
Or you
little
could just be a jerk.
Okay.
15. Y equals sine of xy. All right, I actually do have 2 y's in here that I have to take the derivative of. Y prime. So lose track of that one. All right, now the derivative of the outside. Cosine of xy. Do I have to tack a y prime on there? No, because I haven't taken a derivative of a y directly yet. Times the derivative of the inside has to be product rule, which many of you guys ignore. All right, so if I take the derivative of the first times the second left alone, plus the first left alone times the derivative of the second. And this problem really just got harder than it looked, because I want to put this y prime together with this one, but this one's trapped inside the parentheses, and what's the only way to get it out? I have to distribute this through here. I know. It looks so simple. Right, so I get y prime equals y cosine of xy plus xy prime cosine of xy. The y prime things need to be on the same side, so I'm going to get y prime minus xy prime cosine of xy equals y cosine of xy. Pull out a y prime, leaves me with what over here on the left? Then divide everything by 1 minus x cosine of xy. Y prime equal y cosine of xy over 1 minus x cosine of xy. Can I cancel the cosine of xy? No.
No, bad video.
He's playing for it, I think. That's the problem.
Once we finish the
Why can't I
base.
get it?
Got it.
Here we go.
There it is. There he is.
Oh my.
Uh-oh. He's angry.
Oh. Just this one.
Just this one.
Oh, we failed. You seen the panda?
Yeah.
Okay. He's been privy.
I was showing your camera microphone.
Oh.
Camera cannot be destroyed.
No, I know. It is indestructible.
Probably because you didn't have to build
Deleted.
it.
Okay. So this, yep, this is as good as that one's going to get.
What price was
21.
Okay.
All right, this one, it says find dy over dx using implicit differentiation and then evaluate this at the given point. So xy equals 4, and we're supposed to evaluate it at -4, -1. All right, so we have to product rule this thing. So here's my first term. Here is my second term. So I take the derivative of the first, I get 1 times the second left alone plus the first left alone times the derivative of the second equals the derivative of 4, which is 0. So I'm going to get xy prime equals y, negative y, when I subtract y from both sides. Divide both sides by x, and y prime will be negative y over x. Right? Now, that is my derivative, but I want it at that particular point. So when I plug that in, y prime is going to be negative 4 over -1. That's a positive 4 over -1. That's a negative 4.
It's negative 1.
No.
The book is negative 1.
Hmm.
It's y over negative.
Yeah, it's Y.
Oh, I put my y into
I
my
did it the first time too.
x and my x
And I
into
won.
my y.
I don't touch the face. Show the video.
Oh, come on.
Show the video.
All right, so I get a negative 1 over a negative 4. That's a positive 1 over a negative 4.
Yeah, show the video.
We're done.
Yeah.
No, do it.
Come here.
We're on a time schedule here.
Do it.
2030.
You got tandem, what do you got?